Right triangles. This is the same stuff that we learned in geometry with the addition of the other trig functions. So theta is right here. So the sine of theta is the leg opposite over the hypotenuse. Cosine of theta is the leg adjacent over the hypotenuse. Tangent of theta is the leg opposite over the leg adjacent. And then the other trig functions, the cosecant is the reciprocal of the sine. The secant is the reciprocal of the cosine. The cotangent is the reciprocal of the tangent. Now we want to find the value of theta. Remember, when you're looking for the value of the angle, that's when you use the inverse trig functions. So I could take any one of these three. I'm just going to use the sine. And I know the sine of the function is 8/17. So to find the angle measure, I would do the inverse sine on both sides. So we have the sine of theta equals 8/17. So if I inverse sine on both sides, then the inverse sine and the sine of theta undo each other and leave me with theta. So theta equals the inverse sine of 8/17. So you use the inverse trig functions when you know the sine, cosine, or tangent and you want to find the angle. Then the only other thing is whether or not you're working in degrees or radians. Since we're solving for theta in a triangle, we're going to be working with degrees. So we make sure that our mode is in degrees, and then you go inverse sine, parentheses, 8 divided by 17, close your parentheses, and you get 28.0725. So theta equals 28.0725 degrees. But chances are we're probably going to have to change that into degrees and minutes. So you can times the decimal portion, this part right here, by 60 to get the minutes. So a fast way to do that on your calculator is subtract the 28, that leaves the decimal, and then times that by 60. So it's 4.3 minutes. So 28 degrees, 4.3 minutes. And there's our answer. Next slide. Okay, so angle measures 360 degrees, 60 minutes, 60 seconds. If we're using minutes and do seconds, we'll probably just go to the nearest minute. Probably won't do seconds usually. So give it an angle in a right triangle, find the other angle in the right triangle. Now remember, a right triangle will have one of the angles is 90. That means that the other two angles will have to add up to 90. They'll have a sum of 90. So I can do 90 minus the 38 degrees, 29 minutes. Okay, so if I'm going to answer in minutes anyway, I can just do the 90 minus the 38. That's 52. But then I also had to minus the 29 minutes. So it's going to be 51 degrees and 31 minutes, because what we would do there is you would think of that as 89 degrees and 60 minutes, and then you can subtract 89 degrees minus 38 degrees, it's 51 degrees, 60 minutes minus 20 minutes is, minus 29 minutes is 31 minutes. So on the second one, we would take our 90 degrees minus our 47 degrees, 55 minutes. Well, think of that 90 degrees as 90 degrees, 60 minutes, and subtract. So 90 minus the 47 equals 43. 60 minus 55 is 5, so 43 degrees, 5 minutes. Okay, solving triangles. So if this acute angle is 52, this one would just be 90 take away 52, which would be 38. When you solve a triangle, what you're trying to do is find all the parts that you don't know. So in this triangle, we don't know little b, we don't know little c, and we didn't know big B. So big B is 38 degrees. Then we need to find little c and little b. And we can use trigonometry to do that. So I know this leg right here, so I'm going to take the 52, the angle 52, and I know the leg opposite, I want the hypotenuse. So opposite and hypotenuse is sine. So I'm going to do the sine of 52 degrees equals the leg opposite over the hypotenuse. And then I want to solve this for c. Now there's lots of different ways to solve that. One way is to turn it into a proportion and then do your shortcut where you times on the diagonal and divide. So c is going to equal 12 divided by the sine of 52 degrees. So then we can take 12 divided by sine 52, and we get 15.228. So if we're rounding to the nearest tenth, that would be 15.2 units. So C is 15.2. Now to get B, I could set up, I have opposite and adjacent, or I could do opposite and adjacent this way. So I could do tangent of 38 degrees equals the leg opposite over the leg adjacent. To solve this, I could times both sides by 12. Which would be the same as if you did the proportion and the check mark if you rework that. So you get 12 times tangent of 38 degrees is 9.4. And we have solved the triangle. Now the only difference on the second one is that we start off with this 30 degrees 18 minutes. So then this would be 59 degrees and 42 minutes. But when you're working with the SOHCAHTOA part, you would actually convert one of those into a decimal. I'd probably use the one we started with. So I would rewrite that as 30 point, and then to get the decimals, you do 18 divided by 60, so 30.3 degrees. In this triangle, we would want to find A, which we already did, 59 degrees, 42 minutes. We would want to find little b, and we would want to find little c. I could find little b by using tangent of this angle right here. So I would do tangent of 30 degrees, 30.3 degrees equals, and then I have the leg opposite, which is b, over the leg adjacent, which is 7. Now, once again, I could multiply both sides by 7, or I could think about the check mark and do times and divide, but it's still going to be the same thing. So I'm times by 7 times by 7. Okay, so B equals 7 times the tangent of 30.3. And I get 4.09, and that was B. So B equals 4.1. To find C, I could do adjacent over hypotenuse, so I could do the cosine of 30.3 equals the leg adjacent over the hypotenuse. Use your check mark, times and divide, so it'd be 7 divided by the cosine of 30.3. 8.1. All right, in this last example here, let's get it over there a little closer so you can see it. Okay. In this one, you notice we don't have any angles. So I'm going to have to find an angle first. So I'm going to find angle R first, because I need to find angle R, I need to find angle N, and I need to find little n. So I'm going to find angle R first by using opposite and hypotenuse, which is sine. So the sine of angle R equals the leg opposite over the hypotenuse. sine of angle R equals 1/2. Now I have that memorized. What angle has a sine of 1/2? And the answer is 30 degrees. So R is 30 degrees, which makes N 60 degrees, which makes little n, we can get that by doing the special triangle where it was x, 2x, and x root 3. So it would be 8 root 3. Or we could set up like the tangent. We could do the tangent of R equals 8 over n. Do your check mark. 8 times 1 divided by the tangent of 30. So 8 divided by the tangent of 30. And you get 13.85 or 13.9. And if you do 8 times the square root of 3, you see that that's also the same exact answer. So you can see there's a couple different ways to get that. Okay, angle of elevation, angle of depression. Angle of elevation is from level up, angle of depression is from level down. So we have this problem. The angle of depression from a helicopter to the roof of a hospital is 36 degrees. So you have your helicopter flying right here, and the roof of the hospital over here. From level with the helicopter down to the roof of the hospital is 36 degrees. The helicopter is flying at 600 feet. The hospital is 150 feet. So if we subtract the two, that would be 450 feet from level with the helicopter down to the top of the building. So how far is the helicopter from the landing site along the line of sight? So the line of sight goes diagonal. We're looking for x. So then we see we have the leg opposite of the angle. We want the hypotenuse of the triangle. Opposite hypotenuse is sine. So the sine of 36 degrees equals the leg opposite over the hypotenuse. Let me get that where you can see that a little bit better. Okay, so then you can make a proportion, times and divide. So 450 divided by the sine is 36. 450 divided by sine 36. And you get 765.6 feet. Okay, last problem. So a tower 175 meters tall casts a shadow 76 meters long. Find the angle of elevation of the sun to the nearest minute. So if the shadow's going this way, the sun would be out here, coming down like so. So we're after that angle right there. There's your right angle. And we would then say, from this angle, we have leg opposite, leg adjacent. So the tangent of theta equals the leg opposite over the leg adjacent. But we want to find theta, so this again would be, we need to do the inverse tangent in order to find the angle measure. Remember, when you're looking for an angle measure, that is when you're using those inverse trig functions. So inverse tangent, 175 divided by 76, and we get 66.525 degrees. So theta equals 66.525 degrees. But it says to do degrees in minutes, so I'm going to subtract the 66 from my answer, and then I'll have the decimal, times that decimal by 60 to get the minutes. So it's 31.5 minutes. So 66 degrees, 31.5 minutes.